Hello everybody, I am Orson and I'll be showing you the first FRQ in the 1999 AP Calculus BC exam. So this one is a parametric problem, and question number 1 asks, a particle moves in the xy plane so that its position at any time t, where t is greater than or equal to 0 and less than or equal to pi, is given by x of t equals t squared over 2 minus ln 1 plus t, and y of t equals 3 sine t. Now the first part A, asks us to sketch the particle, path of the particle in the xy plane below. Indicate the direction of the motion along the path. So, since this is a calc active portion, we simply fire up our trusty old graphing calculator, and we'll go to mode, and be sure to set this setting to parametric. Hit enter, and we can go enter our function. As you see here, I've already done that, so we can go directly to graph and get this. Now, we can just simply transfer it over onto our xy plane over here. Starts at 0, 0, goes to just below 3 on the y-axis, and it goes to just above 3.5 on the x-axis. So we simply graph it. And now that we've graphed it, a common mistake here would be to forget to indicate direction of motion on the path. A lot of times we're hurried, we're running out of time, so we'll just simply do this. Oh, we're done, and then we forget this part. So be sure to do that, and the way we do that is we do trace, and then you can see the t value there, and we can just see as increase t by holding down the right button, and we see the path that the particle takes. So it goes this way, so we can just transfer that with arrows, and we are done. Now, sometimes the AP board will give you this on the non-calculation part, and in that case, what you would do would be you would make a chart where we have t, x, and y. You pick a bunch of t values, and you calculate the x value from this function, and same for the y value. And then you can graph it, graph the points, and graph. So now is section B. It asks, at what time t, where t is greater than or equal to 0 but less than or equal to pi, does x of t obtain its minimum value? And what is the position x of t, y of t of the particle at this time? So when we see when does something obtain its minimum value, we should be thinking we need to find the derivative and set it equal to 0. So x prime of t equals 0, which is x prime of t equals t minus 1 over 1 plus t. We set that equal to 0, and move it over to the other side, and multiply this over here, distribute, and subtract a 1, and we get t squared plus t minus 1 equals 0. Unfortunately, we could not factor this, so we need the quadratic formula, which is shown here. And we plug it in, and we get this. However, we now will discard the negative part, and it's positive only, because if you subtract square root of 5, t will become a negative number, and since t has to be greater than or equal to 0, we do not need to worry about that, so it's only the positive part. We get this, plug it into a graphing calculator or scientific calculator, and we get t equals 0.618. However, we also need to consider endpoints, since this is a closed interval, and the endpoints are 0 and pi, as well as when x prime of t equals does not exist. However, for this one, we do not have to consider it, as the only way x prime of t does not exist is if this equals to 0, and the only way that equals 0 is if t is negative 1. However, t has to be greater than 0, so that does not apply to us. Here, next we will test the 3 values that we have obtained, plug into x of t, and we get these 3 values, and t equals 0.618 yields the smallest number, negative 0.290. So now you have to remember to do, we find position, this is a common error, forgetting to do the position, we move on to the next one because we're hurried or rushed or whatever. And this we know from earlier, and y of 0.618, we just plug it into y equals 3 sine t, and we get this number. So our answer for the position is negative 0.290, comma 1.738. So the next problem, problem C, asks at what time t, where t is greater than 0 but less than pi, is particle on the y-axis. Find the speed and acceleration vector of the particle at this time. So to get the time when the particle is on the y-axis, we have to set x of t equal to 0. This is x t set to 0. Then to get when this is true, we fire up our graphing calculator, go to mode, switch it back to function from problem 1, and then I already typed in the function, and then we just hit graph, and then second F4, and then we hit 0. We set a left bound, then a right, and then we hit enter. And then we get x, or in this case t, is equal to 1.285. So next on our list is the speed and acceleration vectors. First, for the speed, we use our speed formula, which is square root of x prime t squared plus y prime t squared. Now, do not confuse the speed formula with the distance formula, which involves integration. The speed formula does not have integration. Now, first we figure out x prime of t, which is t minus 1 over 1 plus t, and y prime of t, which is 3 cosine t. We plug in our t value of 1.285 into x prime and y prime, and we get 0.847 and 0.845. We plug it into the formula, and we get 1.197. Since this is a speed, it will be units per, I believe it is time. It does not specify which time, I believe. Now, we have to do the acceleration vector now, which is a vector, so it's x double prime of t, comma y double prime of t. This is x double prime of t, and this is y double prime of t. And we plug in 1.285 for t, and we get this 1.191, comma negative 2.878.